Welcome to this new series from Pixagon.ai. Uh, and the idea with Pixagon.ai is to be your AI educational station. So, let's just first get started with, um, you know, what AI is. Now, you're all here because you've heard of AI and you are interested to see what it's all about, right? And AI is everywhere today. So, ChatGPT is something that basically changed people's perception of AI. Suddenly, everybody began to use ChatGPT. It was all in the news, and people went, "Wow, AI can actually be something we use in our daily lives." But AI has been around for a while now. AI co-pilots have been around for a while, and they help you do different tasks, including if you're a coder and so on. Self-driving cars are something that's been there from 2010 on, and probably research on that has started much earlier. And the whole idea of self-driving car is for an AI to power the automobile. And now we're also starting to see more and more adoption of expert systems. So, for example, you see here, an expert system is, an automated system that, for example, is able to look at medical records or if it scans and try and detect anomalies. Of course, currently you do not have a robot sitting there looking at it. It would actually be a computer doing the job by itself. But given that the future, seems to be very AI heavy. Understanding AI, learning about it and its applications is going to be quite key, over the next few years. Um, and if you're working, again, AI is already becoming part of your workday, right? Whether it's using a tool like ChatGPT or other AI assistants to help you write, generate charts, and so on. Or if you're a developer or a coder and you need to build AI models, or at least understand how to integrate existing AI models into your ecosystem. And so what we are looking to do with Pixagon.ai is, to try and help you along with this journey, right? So I've had my own share of trying to build AI models and integrate them in projects that I've been working on. And I felt that it would be useful to have a course and a tool or a platform that kind of helps you get started from scratch, right? Where you're not necessarily all that familiar with AI and how it works, but you can really get started and up and running. And if you are familiar, then it can help you, by gathering a lot of resources in one place. So in this journey with us, we'll try and help focus on deep learning, and we'll start teaching you deep learning from the basics. It will be very project and coding centric. So apart from the first few lectures or videos where I just go over general concepts, you'll then start building models that will be initially very simple, not necessarily even fully AI as you call them, but over time, over the next few weeks, you'd start learning how to actually build serious deep learning models. The focus will be on deep learning because it's one of the most powerful approaches out there. We'll also cover important aspects of machine learning, simply because machine learning is a very important tool in general. Deep learning is a part of it, and some of the basics you learn as part of the machine learning curriculum will help you understand deep learning better. And then we'll cover any prerequisites that you need for this course. So there will be coding as part of this course as you actually build some of these models. And if you're not familiar with coding and you're not familiar with Python, you don't need to worry because we'll put lectures out or videos out on getting started with Python and giving you whatever skills you need to be able to implement different aspects of this course. And deep learning and AI in general also involves math. You have to learn topics like understand or know at least the basics of topics like differentiation, matrices, vectors, optimization, and so on. But don't worry if you're not familiar with these, because we'll give you a intro level discussion of these topics to getting you to a point where you actually understand all this. So the prerequisites for this series in general are very low. As long as you know your basic high school math, you understand basics of algebra and so on, you'll be fine because we'll cover pretty much whatever you need to learn as part of other series we'll do in this on this channel and in the platform. And a basic understanding of coding will help. So if you've coded before, even if it's simple, it'll help you. If not, don't worry, because a lot of the coding we'll do will be in Python, and we'll give you enough content or material and practice on Python that you can get good. And so my name is Anil. I did my PhD in Aeroastro from Stanford and started working on machine learning projects, learning about it and then working about it 8 or 9 years ago. And then have really found deep learning and AI very interesting. Have tried to have stayed in touch with the field. And I'm the co-founder of Pixigan as well, where we are trying to create an ecosystem to help you out with AI and AI knowledge. So for the rest of this video, we'll just discuss, a little, give you a basic outline of AI just to get you started. No coding, nothing intense in this session, and hopefully you'll not find anything intense actually. So, what is AI right now? So we just use a definition by the great Alan Turing, who was one of the people who defined or at least got us started. And so AI is defined as the science of making intelligent machines, right? So basically, the idea is, can you have a computer, right? Look at some problem, understand it, analyze it, and do something, take a decision, right? Um, so it could be as simple as, whether to, send an email, or can it, drive a car. These are things that people do in their daily lives, but it's quite complicated for a computer to do something like that. So the vision originally was to create machines that can perform tasks that only humans can do, right? You can't have an animal like a dog or a cat or a horse drive a car, right? You don't need a human to do that. But could you get a computer uh, specifically, but a machine in general to do that, right? Um, and the robot you see here is an illustration of sci-fi, right? What you thought, a system can do. But a lot of the time, you don't actually have a physical being or a robot, something physical actually sitting there. It's just a computer hidden in your car. So modern cars, for example, all have hidden chips, have chips in them that control the car, right? So let's just do a quick history of AI, and if you have the time, please do check out pixagon.ai/storyline, where we're documenting, the evolution of AI over the years. Give you some of the key points. So first, AI code was written in the 1940s, but then Turing test was one of the first was where Alan Turing kind of defined a way to try and analyze or understand, if a system is actually an AI. And there are obviously people who believe this is the right way to do it. There are people who believe that the Turing test is not the right way, but it was one of the first definitions of, if an AI passes test, it would be considered to be an artificial intelligence. And ChatGPT 4 actually is considered to have passed this test. Now, the term artificial intelligence was actually coined later at the Dartmouth conference, which was a conference of some of the great minds at that time. And over the 6 weeks of that conference, they actually really sat down and tried to understand what artificial intelligence would be. Another big breakthrough was the introduction of the concept of a perceptron, right? And you start understanding what a perceptron is as you go through the next few lectures on deep learning. It's effectively where they began to connect, the idea of how a human brain functions, and could you kind of model that, right, with neuron, a mathematical. A number of other developments happened in the next few years. I'm just picking a few, but the backpropagation algorithm by Jeff Hinton, which came out in 1986, was one of the key networks, or one of the key developments, because deep learning involves training or teaching a system, a computer, how to learn, right? And backpropagation is the standard technique used today for deep learning models, and it kind of came out in 1986. Now, a few examples in the early 90s of interesting applications. Handwritten digit recognition came out in 94. This was to help, services like the Postal Service kind of understand addresses and locations and so on. And then in 97, Deep Blue, which is an AI developed by IBM, defeated Gary Kasparov, who's one of the greatest ever chess players, right? So it defeated him in chess. And that is kind of a seminal moment. A lot of developments in the late 90s and the 2000s, but looking at something that you've probably used, Siri, which is a virtual assistant on Apple systems, came out in 2010. Is a really good example of an AI. And then some interesting developments. Facebook came up with Deepface, which really kind of took facial recognition technology to the next level. And then the seminal paper in in natural language processing, right, which is basically computer being able to communicate in a language that you understand, English. Till then, you had to write code and stuff. So could you get a computer to understand human text? And transform the paper on transformers, which came out in 2017, was a game changer. And a lot of the AI developments in the next few years till now is based on that. So 2018, Google came up with BERT, which kind of again was really an upgrade on existing language processing tools. GPT-2 came out in the same phase. By 2020, you had GPT version 3, but again, it was for limited use. It wasn't really, there wasn't an app that you could use it on. All of these are based on the transformer model. And then in 2021, GitHub came up with its GitHub Copilot, right, to help people who are coding kind of simplify it. It would help people debug code. It would complete code for you, find errors, and so on. And OpenAI released DALI, right, which a lot of you have probably used. It is a way to generate images, and it's now linked with ChatGPT. You can use DALI from ChatGPT. Then, of course, the key kind of watershed moment was in 2022 with the release of ChatGPT. ChatGPT kind of changed the game because AI became commonplace. Till then, there's a lot of interesting work happening. As you can see, AI didn't like pop out off the ground in 2020. It happened in the early 50s, right? But kind of that was when everybody went, oh wow, we can actually use this in our day-to-day life instead of it was an abstract concept that you saw in sci-fi movies. So a quick outline on AI is it's a very interesting history and a lot more actually incidents, events, papers, developments that I'm not covering in this lecture. But I might do a video on just the history of AI. Um, so what are the advantages of AI? Why is everybody so happy with AI, right? So there are quite a few, and I'm just listing a few that are quite important and you actually can relate to, right? So the most important that we all find is automation of repetitive tasks, right? So there are a lot of tasks in our day-to-day life or otherwise that you have to kind of keep doing every day, and it can help you. So, for example, in an industry setting, if you have quality control and you can just use a camera and the AI can detect errors, it kind of makes life a lot easier for the system, for people. You have fraud detection systems that are used by big companies, including companies like Amazon, but a lot in banking, right, where they have to detect. So if you've got a message from your bank saying, "Oh, I detect that you've done a bad transaction," it's probably an AI sitting there. It's crunching through a lot of data, and depending on the different parameters of the transaction, maybe you've done it at 12 at night, and normally you only do a transaction in the day, or maybe your transaction is from a city in France and you're actually based out of the US, for example. So AIs are able to kind of go through them very, very quickly. A human being would take a lot longer. It increases efficiency, and this is one of the reasons why ChatGPT has gone really viral, right? It's very easy for you to write things, which is something everybody struggles with. We all struggle with writing reports and writing articles and writing email drafts, and ChatGPT can really help you with that. It can help you summarize reports. You can have virtual assistants that kind of set reminders for you, can set up calls for you, schedule emails, and so on. So these are other examples of AI advantages. Then, of course, just the fact that if it's an automated system, it's a computer running it, right? And so it really makes scale possible. And these systems, some of them run on massive, server farms. So, that's another thing. And in scenarios also like medical diagnostics, where again, it's an image, and an image has a lot of pixels, and you're trying to pick out, or try and diagnose. So that's another example of how data handling and decision making can be improved and optimized. And of course, you have personalization. You're all familiar with personalization. You've just probably not realized it yet that it was an AI doing it, maybe. Or maybe you have, for example, where you kind of have chatbots that you talk to, whether it's your bank or it's on Amazon or whatever. You have Netflix that shows you movies based on what you've liked. And Netflix actually had a contest in 2010, I believe, around or 2008, where they actually were trying to improve the recommendation algorithm based on it. And then AI co-pilots, which assist you clean up your writing, clean up your code, clean up any job you're doing, making life easier for you. So AI actually effectively makes life a lot easier for people. It makes you more productive. But there are also a lot of challenges associated with AI, right? So one of the first ones is bias coming in. And an AI system, including the latest systems that are out there, are all prone to bias because at the end of the day, the AI is only as good as the data it's trained on. So if you train it on information that is biased or lopsided, the AI is going to basically give you outputs that are based on. And that is a risk. That is a risk because if you're writing things or you're having it generate images, you can see issues. In fact, I think Google had one recently. Um, Also, depending on AI models are not very transparent. Deep learning is, deep learning models. It's very hard to figure out why the model is giving you the output. It's just a collection of weights and parameters or numbers, and it's very hard to figure out why the AI model is giving you. So transparency becomes a problem. You don't know what the reason for an output is, and it also results in a loss of control, right? And over time, you kind of feel the AI is going to do the job, but you don't really know if it's capable of it. Right? Then you have the issue of cost and environmental impact. So AI systems are very energy consuming. They run on big servers, so there's an environmental impact to running large AI. There's an economic impact of everything. So already people are worried if their jobs are going to be taken, and of course people have to be retrained or have to understand, okay, how do I integrate AI into my life or my job? Probably a reason why you're also interested in this series. And then AI also, you have to pay for AI systems, right? They are expensive. So it's possible that, people who can afford it end up being more productive or being better. And of course, there are a lot of risks associated with AI when you actually use an AI as a user, right? So first of all, you don't know, in terms of privacy. And privacy infringement is in multiple ways. You could be entering your data into an AI, maybe ChatGPT, and you don't know if it's training on it, even though, OpenAI, for example, has very good systems to make sure that that doesn't happen. But you never know, right? You're using different kinds of AIs. It's also possible for other people to use AIs to, kind of come up with code and modules and things like that to look into your life, right? Which is a problem. Um, Security risks come in because AIs can be prone to cyber attacks. We're very early in the AI system, and systems are not very well known, or flaws are not yet fully well known. So that's a problem. Obviously, there are ethical concerns in terms of should an AI be making a decision. You have a car that's being driven by a system. How do you know it's going to make the right decision, for example, right? And then one big problem we're already seeing today is how AIs can be used to kind of create misinformation on a large scale. Deepfakes is already a problem. So AI is not without its risks, but the hope is that the benefits associated with AI will outweigh its risks. Either way, it's good if you are aware of what AI is capable. Now, a term you hear very commonly associated with AI, and that's something we will, a lot of the work we're going to be doing is effectively in this field is machine learning. And so Arthur Samuel, who's one of the pioneers of AI, came up with some very early AI models and algorithms as early as the 1950s. He came up with this very interesting definition, which says machine learning is the field of study that gives computers the ability to learn something without being explicitly programmed for that task. So, for example, if you are telling a computer that, if a computer sees, you know, a particular image that looks like this, and you give it a copy of that image. And you say, if it sees this exact image, then it's supposed to do something. It's supposed to move to the right, for example. That's explicitly being programmed, right? On the other hand, if you've just given it a collection of information and it's trained, and then when it shows up on the road and it sees a person, it knows it hasn't seen that person or that scene or that particular image ever before, but it already knows how to respond. And that's machine learning system. So it's a discipline of AI. There are different types of AIs. We'll not go into that now. We can do a separate lecture on that if required. And machine learning algorithms are mainly classified as supervised learning. And in supervised learning, you have data. You're giving a system data and you're supervising it. You're telling it this is the data, this is the input, this is the output. So if this is your input, this is your output. Now the system learns that and then is able to figure out if it sees an input, it doesn't show up in this, what to do. With unsupervised, you're not really specifying what the output is. You're just giving it a lot of data and getting the system to understand and see patterns in it. Right? You're not telling it what the right answer is. And with reinforcement learning, it's where you're giving a system rewards, right, to come or arrive at the right answer. So reinforcement learning, for example, is used a lot in game playing, right? If you have a system that plays chess on its own, or even something as simple as tic-tac-toe, right? It's based on a system that's trained in a way where it understands the benefits of playing the game a certain way, and if it makes the wrong move, it understands as it's trained, that it's a bad idea. Now, reinforcement learning actually is becoming very prominent with language models as well, where you're teaching it not, for example, to come up with abusive or bad content. You're teaching it not to do certain things. And reinforcement learning is applied on top of the existing, on top of a pre-built model. So ChatGPT, for example, would have been trained on a lot of data. And then there'd be additional reinforcement learning to make sure that it respond when you ask it a question, it responds the right way and it does not, use bad language. So it's become very important. It's already important, but it's become even more important, with language systems becoming so key. Okay, so let's look at an example of roughly what a machine learning workflow would be. And this is something that would be useful. So as we kind of start actually solving deep learning problems and machine learning problems, you kind of understand what we're trying to do. So the basic idea, let's take a problem of detecting a face in photos, right? What you do is first you collect your data. Now, if it was a different problem and you were trying to predict the price of a car based on a lot of parameters, for example, you'd use, a table of numbers. In this case, your images. So you need to collect the images that you want the system to learn from, right? So, for example, if you're detecting, if it's just a general face, you probably need a number of images of people in different scenarios, in different environments. Then what you do is pick the machine learning or AI model you want to apply to that problem. And as you do this course and this series, you start understanding which models are best. So for its image, you'd probably use a convolutional neural network, and those would work best for images. Next, you'd have to clean the data, right? So what you'd have to do is take out images that are corrupt, take out data sets that are invalid, that could mislead, the AI. But you also need a good collection of images. So you need images, for example, with faces and without faces in different environments to make sure that the AI system works well. Then what you do is break the data into a training set and a test set. So you take some of the information, and that is what the algorithm would actually learn on. And then you'll have a test set, right, which is what you test on. And test is not your actual use case, right? Because what happens is when you start training on, on some data, the machine really learns to work on that data. So the accuracy will generally be a lot higher on that data set. But now when you apply it to some other, scenario that it's not seen, it's probably not going to be that high. So what the test set does is give you a real understanding of its accuracy in a more real world scenario. So your training accuracy will sometimes be a lot higher. But when you actually test it on data that it hasn't seen, you realize, oh my God, I need to train this a little more because it's not as accurate as I thought it was. And finally, when you are quite okay with your model, you think it works to the level of accuracy you want, you deploy it, either to a cloud or to your, edge system, which is, it could be your, a system monitoring, let's say packages, in an assembly line, so on. And then over time, you'd have to go back. If you have more data, a data that's different, you'd probably have to go back and retrain or update your model, right? Okay. So that was the basic idea with machine learning. Now, what is deep learning? Right? So deep learning is a type of machine learning model, right? Or a machine learning algorithm that's actually very powerful and is what powers most of the AI applications today, right? Including ChatGPT and Bard and Gemini and all the AI models that you use on your day-to-day basis. And so the reason it's called deep learning, and we'll go into this a lot more in the next set of lectures, but it's basically because it uses, it. So deep learning primarily uses a neural network architecture, and it's deep because it has multiple layers. We'll describe this later. So a lot of the focus of this course is going to be about different deep learning models, how to apply them to different applications, so that by the end of it, you kind of understand, you at least have an understanding of, depending on the problem, what model is most relevant to you, and you have a way to quickly get up to speed and build your model, right? Okay. So that's going to be the next lecture where we're going to start getting into the basics of deep learning. So hope you enjoyed this and hope you will stay with us for this entire series, and we'll help you out, whether it's just trying to understand deep learning for fun or if that's your career. Thank you.